Okay, so in this video, we're going to start talking about graphing of rational equations. Now, we should have already taken a test or been working on rational expressions where you simplified, add, subtract, multiply, divide, and solved equation with them. Of course, they were a lot more intense looking than the one that we're starting on with graphing. But let's just talk about one of the things that anytime we did simplify, we always had to write down our excluded values. So again, let's go back in there and remember what our excluded values are. So in this case, we know that x cannot equal 0. That's our excluded value. And so what we do is we call that a value, actually, that x equals 0 equation, that's going to become what we're going to call our asymptote. Okay, the definition of an asymptote is a line that our graph is going to get closer and closer to without crossing. So line that we're going to get close to but never cross. And we use those a lot when we're doing rational equations. So we're going to go ahead and draw that in. So I'm just going to use red so you can see it. So if I'm saying anywhere x is 0, I cannot be. So it'd be like 0, 0, 1, 0, 2, so forth. So that is actually this line. So what it means is our graph is not going to cross this line here. Okay? So we are going to go ahead and just do a quick check to see. And the easiest way to start off with this is look at a t-table. Okay. And so let's just start over here and we'll put in, let's say, the number 1. And so 1 over 1 is 1. So that would be the point 1, 1. If I put in a 2, I would get a half. Okay. I'm going to put in, let's just go ahead, I'm going to put in 4, I'm going to skip, and that would give me 1/4, so forth. And if I keep going, so let's say I go 8, that would be 1/8, okay? And again, it's going to keep getting closer and closer. Mine looks like it did touch, but just think about that. I could go up to 100, and I would still just be at 1/100th, so I'm not actually going to touch that line. Now let's look over on the other side. What if I put in 1/2? What would happen? Well, I would get 1 over 1/2, and hopefully you know the reciprocal of that. That would be 2. So at a half, I'm actually up at 2. And so if I was at 1/4, that would be 1 over 1/4, which would be 4. And so forth. So what we're really going to have here is this graph, I'll try to do it, that's going to be it's going to come very close to the x and the y-axis, but it's not actually going to touch. And I know mine looks like it does on there, but it actually doesn't touch. So that's what our graph is going to look like. Now what happens then is when we do our reflection over here on the other side, if I put in let's say a -1, then I would have 1 over a -1, which is a -1. It's going to be right here. And if you start thinking about it, it's actually just going to be the reflection over, in this case, the y equals -x line. But it's going to look the same way. It's just going to come down in through here and then again get closer and closer and never touch. So those are reflections of each other. So that is what our graph of y equals 1 over x looks like. Now, in fact, it's going to look the same if I have y equals 2 over x. Okay? The only thing difference is where we're going to start at. And the other thing too, let me go back in here, is that you notice it also gets closer and closer to the x-axis without crossing it. So we actually have 2 asymptotes here. Both of these are actually our asymptotes. So we have not only x equals 0, but y equals 0 is also our asymptote. And that's actually going to be true of any of our graphs that look like this. Now I say that's going to be true. They're going to slide up and down, but it's going to still look the same in terms of our asymptotes on there. But let's just start with this one here. And let's look at what happens when I do put 2 over, and just see if you can see what would happen. So again, if I put a 1 in there, now it's 1, 2. Let me do this in a different color. Let's go purple. So I'm now going to have 1, 2. If I put in, let's see, 2, that would be 2, 1. Okay, and if I put in 4, that would be a half. Okay, and if I put in, let's go put in 8, and 2 over 8, whoops, I put that in there, 2 over 8 would be a fourth. So way over here at 8, I'm at 4. So you can still see I'm still getting closer. So the only thing that actually happens, and I could go in and put more numbers in there, let's put in a half. So 2 divided by a half would be 4. 1, 2, 3. That'd be a 4. Okay, so what it actually does to my graph is it just moves it away from the origin there. It's just going to push it out. And so it's also going to do the same thing here. See, that needs to hit at right here. There we go. And so, yes, it's going to just make it come out more. And eventually it's going to cross. So if I had a 3, 3 would just come out more. Okay, so that's what's going to happen when you have a number over x. That's what my graph's going to look like. Okay, so all of them, if you have, let me just make a little note down here. If you have y equals, and I'm going to put a k, meaning any number over x, then we have our asymptotes, okay, is x equals 0 and y equals 0. Okay, that's always going to be the true. And when k gets bigger, it just moves it out. Okay, so it's going to move it further out from the origin. Okay, and they are reflections, and they are in quadrant. That would be what? 2, 1, 2, 3, and 4. Okay, talk about our quadrants. So all of those are going to look like that. Now, if it is a negative, okay, so if your k is negative, okay, less than 0, then what it does is it moves it to quadrants 1 and 3. So if your k is negative, then you're going to end up having your graph out here. Okay, so it's going to come in here. Whoops, not quite that steep, but come in there like that. Okay, sorry, had it on eraser. There we go. Anyway, if it is negative, it's going to flip it into these two quadrants. Okay, and it'll look something like that. Okay, so that is if it is y equals 1 over x. Now let's talk about what happens if we happen to add a number to it. So I'm actually going to go to another screen. So we're going to look at what happens if I take y equals 1 over x and I add, let's say we're going to add 2 to it. Okay, so again, x can still not equal 0, so that is my asymptote. It's going to be x equals 0. So I'm going to come in and I'm going to go ahead and draw that back in. So that didn't change. Okay, but what I did was I added 2 to it. So let's go back to our points we had earlier. So if I put a 1 over 1 plus 2, so that's going to give me 3. So I'm now at 1, 3. If I put in a 2, then I'm going to get 1 half plus 2 is 2 1/2. Okay, and hopefully you see what's happening here. If I put in a 4, I'm going to get 1/4 plus 2 would be 2 1/4. Okay, 2 1/4. And so hopefully what you're seeing now is that what it did to my asymptote, instead of it now being at my x-axis where y equals 0, it is now up here. I've moved it up 2. So my other asymptote is at y equals 2. Okay, and so from there I should be able to just go ahead and graph, because now I kind of know what's going on. So these are, sorry, it's kind of jaggedy there. And then this one again is going to be the same. and it's going to come in here. And I don't ask you to be perfect with those, but just drawing in your asymptotes and sketching in kind of your graph, and you can always sketch in a point or two. So what do you think then it would look like if it was a -2? Okay, what would be my asymptotes? Okay, and hopefully you realize I didn't move it left or right. Okay, so it's still x equals 0. And the other one now would be y equals a -2. So when I go to graph, and this will show you how easy these are, if you know the basic graph. I should have moved that up some. Actually, let me move that line there a little bit. Okay, so I'm going to go ahead and sketch in my asymptotes. They're here. The other one is at a -2. And then we just sketch in our graph again. And generally it always goes through the 1, 1. So in that case, that would be my 1, 1. Okay, this would be my 1, 1 in this case. And there's my graph. So that's how easy it is, guys, when you're moving those. We're just moving them up and down in this case. So what do you think would make it move left or right? Okay. So my question was, what do you think would make it move left or right? And hopefully you remember that if we put numbers in the denominator, then that's going to move it left or right. Okay, because this is with my x. My x is my left or right. But let's go ahead and do a quick t-table. So if I put in, well, first off, I guess we should start, what can x not be? So x cannot be, in this case, a -1. So I moved my asymptote line to here. Okay, so now it looks like, if you think about it, I've just shoved my graph to the left on there. I didn't change the other asymptote, oops, I'm trying to get that to change colors. So it should still be at 0, y equals 0, but we'll check and see. Okay, so let's just put in a number. Let's put in 1. If I put in 1, I'm going to get 1/2. So 1, 1/2. Can we put 0 in this time? Yeah, because it would be 1 over 0 plus 1 equals 1. So it's 0, 1. Okay. If I put in 2, that would be 1 over 2 plus 1 would be 1/3. So 2 is at 1/3. And again, you see that graph going there. Now I could go ahead and put in, let's see, a -1/2 if I wanted to. So -1/2 plus 1. So that would be 1 over 1/2, which is 2. So at 1/2, I'm at 2. There you go. Now we see our graph coming in here. Okay, here it is. And again, we're still not changing our asymptote. It was at 0. We could draw that in now because we're like, yeah, we were right on that. Okay, so what that means then is my other side of my graph, again, now I told you it always hits kind of 1, 1. So you got to look at where your asymptotes are. So this is kind of my, it's not the 0.11, but it's 1, 1 from my asymptotes. And then I'm just going to come in. Whoops, that should not cross over, but you know what I mean. Okay, and there's my graph. Okay, and that's what it's going to look like. So let's just go back in and then look at what we've got. So notes, if this is my basic graph, my asymptotes are y equals 0 and x equals 0. So let's just make us a little table here. Okay, I'm going to scroll back here. So equation. Okay, if it's y equals 1 over x, my asymptote is x equals 0 and y equals 0. Okay, if my equation, let's go back up, had 1 over x plus 2 or minus 2, okay, that just moved my, so y equals 1 over x, and we'll say, what do we want to, let's call this h, plus h, okay? So that means my asymptote is going to be at 0, and again, the other one would be at h, Okay, now if H is positive, it's going to move it up. H is negative, it moves it down. Okay, and we could write that in there. Okay, if H is greater than 0, it's going to move my graph up. If H is less than 0, it moves it down. Okay, then we had what happens if we put, actually I want to call that K, don't I? Let me back up, because it's HK, that's our points that we used earlier. So we're going to call this one K. Just change that to a K. Change that to a K, guys. So it's HK, it matches our others that we do. And this would be our H. Hopefully you remember that. HK with our quadratic function. Okay, and then same way, if we had it plus H, now that's moved it left or right. And so my new asymptote become X equals H. And my other asymptote went back to y equals 0. Okay, and so we'll put in here if H is greater than 0 on there. We can put in, leave it as a minus, I guess there. If H is greater than 0, because I put a minus here, guys, then that is going to move it to the right. And if H is less than 0, it should move it left. Okay? And we can double check that and make sure it's right. So this was plus, so that was actually a minus. So this is X minus a negative 1. That moved it left. Okay? Which is what we said here. Okay? So that is the basic equation, moving it left, right, up, and down. Now we'll talk about when we do some other modifications to our equation.